All right, in this level 3 problem that you see on the screen, um, there's an added piece to it. So let's just work through it and see what happens as we go. So in this problem, is read it. Again, I usually read these physics problems at least 3 or 4 times, if not more. Each time I read it, I try to extract a little bit more information. So what am I solving for? Right now, the question asks, what acceleration does the car experience? So we're solving for acceleration. What am I given? So I see 3 numbers in the problem. Sometimes we're given things that are not numbers, the words tell us. But if it gives you numbers, that is automatically something you're given. So we're given a mass of 2,000 kilograms. Again, the units tell us kilograms is a unit of mass. I see 2 numbers with newtons, so I know I have 2 forces. One is from the engine. I'm going to call that F. And one is a friction force. We call friction force F of F. And that's 250 newtons. My next step is to draw the diagram. So I have this 2,000 kilogram SUV. Draw it as a box. We know that any object with mass has weight pulling down. We know that an SUV, which is a car, is on a surface. It's not floating in the air. It's on the ground, the road. So it's going to have a normal force going up. Next, we know we have these 2 other forces, the 3,500 and the 250. Well, it doesn't matter which one's right and which one's left. So I picked the 3,500 going to the right. And we know that friction opposes the direction of motion. So the friction force is going to go in the opposite direction here. And this is because the object, if we say the object is moving to the right, the engine's pushing it to the right, and the friction's going the other direction. So our next step is to pick an equation. So the equation that we know is that the net force is equal to mass times acceleration. Well, in every problem that we've solved so far, net force equals mass times acceleration was the same as just plain F equals ma. There was only one force that we were thinking about, and so that was we just dealt with it as one force. Well, in this problem, there's more than one force acting in the direction of motion. So let's see what happens from there. So to find what the net force is, it's actually 3,500 minus 250. That's because if we look at this, the car is moving in the horizontal direction. And since it's moving in the horizontal direction, we need to find the net force in that horizontal direction. Well, even though there's 4 total forces on our diagram, only 2 of them are in the horizontal direction, F and F of F. So those 2 are the ones that we're going to focus on. And we do what we did earlier in the semester when we were just focusing on finding the net force. So 3,500 minus 250. That gives you the net force. Well, that is going to equal mass times acceleration, where the mass we substitute in the 2,000. And the A, we don't know what acceleration is. That's what we're solving for. So I can't substitute in for it, so I just leave it as A. I'm going to simplify this expression. So 3,500 minus 250 is 3,250. And again, that equals 2,000 times A. Now I need to get acceleration by itself. If you think about the algebra here, the 2,000 kilograms is in the way. So to get rid of 2,000, we have to do the opposite operation. So right now, 2,000 and A are multiplied. So the opposite of multiplication is division. So if I divide both sides by 2,000, I'll see that the 2,000 cancels, and that will leave acceleration by itself. Remember that if you do something to one side of the equation, in this case dividing by 2,000, you have to do that same thing to the other side. So that's why I divided both sides by 2,000, not just one side. So if we rewrite this, I say acceleration is 3,250 newtons divided by 2,000 kilograms. And that will give me my answer of 1.63 meters per second squared. And I have an answer for acceleration. I look back at the beginning and I was solving for acceleration. So I'm done. I found the solution that this SUV, 2,000 kilogram SUV, with given these different forces acting on it, was able to accelerate at a rate of 1.63 meters per second squared. So look back at this problem and note the difference between the previous problems. The key difference here is that we had to find a net force before we could move forward with the solution. So what do you think about that, Skeletor? Oh, I like it a lot. Physics is great. There you have it.